Team, my name is Pawan, and in this video I'll walk you through the backend architecture of our RAG chatbot, which is Retrieval Augmented Generation Chatbot. This chatbot is built for enterprise scale AI applications emphasizing performance, cost optimization, and reliability. First, I'll explain the key components of the system like Cosmos DB, Azure AI Search, and application insights, and why they are important. Then I'll show you how a user query flows through the system with an example. Let's get started. Before diving into the workflow, let's understand the main components of our architecture and the roles. First is a Cosmos DB. What is Cosmos DB? Cosmos DB is a globally distributed multimodal database service. In our system, we use it as a semantic cache to store frequent queries and the responses. Why is it important? Semantic cache reduces API cost by avoiding repeated calls to the LLM. If a user asks a previously asked question, the response is retrieved instantly from the Cosmos DB, improving latency and saving resources. Then comes the Azure OpenAI embedding model. What is it? It's an embedding. It's an OpenAI provides pre-trained models that can convert text into vector representations. These vectors capture the semantic meaning of the text. Why is it important? Embeddings allow us to perform semantic searches, ensuring that the system retrieves the most relevant documents based on the user's query. Then comes the AI search. AI search is a cloud-based search service that indexes and retrieves data based on vector similarity. Why is it important? It helps us find the most relevant documents related to the user's query. For example, if a user asks about health plans, Azure AI search retrieves documents like employee benefits guide or health insurance options. Then comes the LLM model, GPT-4. It's a language model capable of generating human-like responses based on input data. Why is it important? Once relevant documents are retrieved, GPT-4 generates a concise and accurate response for the user. Then comes the application insight. Application insights is a monitoring and logging tool that tracks system performance and errors. Why is it important? It ensures system reliability by capturing metrics like query response times, API usage, and error logs. If something goes wrong, it helps us debug and fix issues quickly. Now that we have covered the key components, let's see how a user query flows through the system. I'll use an example to illustrate this. World health plans are available in Contoso Electronics. The user types in the user interface what health plans are available in Contoso Electronics. The system looks in the Cosmos DB to see if the response to what health plans are available has already been stored. If the response exists in the cache, the system immediately retrieves and displays Contoso Electronics offers HMO, PPO, and dental insurance plans. If the query isn't cached, the system sends what health plans are available to Azure OpenAI embedding model to generate a vector representation. The vector representation is used to search for document. This vector representation is stored in the AI search. It compares with the AI search and retrieves the documents related to health plans and Contoso Electronics. It retrieves documents like Contoso employee benefits guides and health insurance options. The retrieved documents are sent to GPT-4, which generates the response. Contoso Electronics offers HMO, PPO, and dental insurance plan. The generated response is now stored in Cosmos DB so that the future queries about health plans can be answered instantly. The user sees the response. Contoso Electronics offers HMO, PPO, and dental insurance plans. Throughout this process, application insights plays a crucial role in ensuring the system reliability. For example, a user asks what is a company's vacation policy. If there is an error in retrieving the response, Azure Application Insights logs the issues, including details like the timestamp, error code, and stack trace. This allows us to identify bottlenecks and resolve them efficiently. That wraps up our backend walkthrough of our RAG chatbot. We explored the key components, their importance, and how a user query flows from user interface to cache and cache to OpenAI embedding model and then to LLMs, then gets output. We also reviewed an example to demonstrate how the system responds in real world scenarios, like what health plans are available in Contoso Electronics. That's it. And adding on, the user and user interface is called the client side, and the remaining whatever the backend is going on is a server side. That's the end of it.